Okay, we're going to be working on some fixes from last episode. We're trying to fix our lowest mouse stone stack order when we're trying to drop stuff. But let's just take a look at where we're at here. So we can drop stones in this first one to lock in our stones in hand locked. Then we can pick orthogonal free spaces, and once we click that, it'll be dark green, and then we can drop more stones. Now we need to fix the stack order render, because see that black stone is rendering smaller. That's because it's a stack order of 2 instead of, it's the same mouse stack order. So it's like, I need to figure out how to rethink that, how to fix that. So we can drop stones no problem, then our lowest stack order is 4, yet when we press up, we can't perform arithmetic on stack order because it's a nil value. On member 27. So yeah, it doesn't have a stack order once we pick it up. So maybe we can, if we take a look at where we drop, here. Here for the first movement grid, we can drop stones. Where's that stack order? We assign the stack order from our grid into our mouse stone. This is where it's messing up, I think, but it's like, it's hard to imagine the fix. Let's just take a look at our mouse stone stack order, which I think we're rendering, and just kind of pay attention to it while we mess around. So we're gonna move type move our lowest mouse stone stack order, which is this bottom value here. So 1 when we have 1 stone, which is right. See, so even this is a stack of 3. The lowest mouse stone stack order is 1, and now it's 2, and now it's 3. Back to 2, back to 1. Yes, so whatever in our mouse stone occupants, lowest stack order is whatever value of the stack order, whatever stack order field in our lowest member in the stack. So I think what's screwing us is when we drop everything, our lowest stack order will become 0, and it's not coming back to 1 for some reason. So let's just see if we lock in there, we lock in here. Now lowest stack order is 2. Now it's 3 because this is the third, and stack order is controlling the render size. So it's like, this is a third, the size of a third stack. It's stack order of 3 size, which is smaller. But there is no stack order at 4. So if there's no occupants, we need to say, see, this is so tricky because we need to be able to pull the fix is complicated because we need to implement the fix within fixing our stack order upon dumping it. So maybe, let me see what crashes again and see if I can't figure out a game plan for what to do next. So we lock it in, we drop 1, we drop 2, we drop 3, stack order of 4. Now if we press up, it should go back to stack order of 3, but it doesn't. What if we say, and it looks like our lowest mouse stack order. Okay. So we'll need to add enter to lock in this first movement stones dropped, but we need to enable picking them up, which isn't happening right now. But what's weird is it's not even happening. It's not even happening if we have a occupant in our mouse stone even, which I thought would have been the cause for it to be broken. So we drop one, and we can't pick up one even right now. So we need to fix that first of all. How come we're not moving the grid from, actually, yeah, we're trying to put a member into our mouse stones, and the one we're doing is our current space. So this is hard to read here, but this is saying the space we clicked on in that occupants members table at index, however many occupants are in that grid. But actually, the occupants, because yeah, we're trying to put the top stone. Now, I think if we drop one, we need to say occupants gets increased right away because we're doing the occupant logic here. So do we have that for our pickup stones over here? We don't. We do the mouse stone occupants, and then we do this occupants, but doesn't that work the same way? Yeah, we've got them right here. So what if we do this first? We decrement the occupants. Actually, hold on. Because yeah, we need to take however many occupants are in our move locked row and column, however many occupants are in there at the point of picking up a stone. So maybe it is this. I don't think dropped in first movement is messing up. I feel like the lowest mouse stone stack order is messing up, but it's not actually. I mean, it's messing up when we press up. So when we press up, our mouse order gets lower. Yes, because we're picking up a stone. Like we have one more stack beneath it, or we have one more. Our index is one beneath at that point. I don't get why this is not working. Let's make sure our move locked row and move locked column are the same. Hold on a sec. I think let's walk through our downwards, dropping a stone. So we increment how many we've dropped in first movement, which will allow us to only pick up what we've dropped. We play the sound. Then we assign the bottom stone of our mouse stone. We assign all of its variables into a grid move locked row, which is our updated first movement grid space. So we drop it into that space, into the members table at its current occupants plus 1. So we do that because we're putting a stone on top of what's currently in that grid. So we need to put it not at the current members, or not at the current occupants, but at the occupants minus 1, or plus 1. Now, that makes sense. Then we decrement how many occupants we have. We update how many occupants are in our grid. Then we nullify our old members in our stone. So when we pick up a stone, we're saying, see, I don't know why we would have to decrement this lowest mouse stack order here. When we pick it up, we have it, yeah, in our other logic, we have it up there. So the first thing we do is we decrement our lowest stack order so that we can place into that new stack order. Now, I'm kind of curious if we just put this after, what that changes for us. Still doesn't do anything. Still crashes when there's nil in there. Now, the crashing at the nil, when we're picking it up and our mouse stones members are nil, that's the reason we had initially kind of locked in the occupants greater than or equal to 1 upon this one, or greater than 1 upon our stones hand locked, but I don't get why this is just so jacked. Let's see. So lowest mouse stack order, when we press up, should get lower. It should, because like when we had nothing, it was 4 because we had dropped 3 stones. Now when we pick up 1, it should shift that lower by 1, so it'd be 3, so that the thing it picks up is the third stack order. See, this is tough because we get a new stack order once we place it in a grid, unless the grid is taken is exactly equal to how many we took. Like, we took 3 from a grid, meaning the first one we drop in an empty space would be a stack order of 1. So the stack order's not changing. That's the only time that this should be working okay, but it's even not working okay upon that. So we decrement our occupants, sure. Why does it crash though? Why does it crash? Now, we decrement our lowest stack order so that we're modifying the original stack order of that stone we just picked up. Actually, see, this is different. We're not trying to take how many, actually, yeah. It's like the amount of occupants would give you the index of the highest most stack, and that's what we're doing right here. And we are updating the occupants of that space upon dropping one. So I don't get why it's crashing. Then we nullify the topmost stone in our grid, which is our occupants. Yes. I don't get why it's crashing. Let me see if we turn this off. We don't nullify these. Does it still crash when we press up? Okay, I'm gonna press up. Doesn't crash. If I do it again. Okay, spamming up and it doesn't crash. Drop 2, spamming up. Oh, did that worked? Well, it worked for picking up 1 but not nullifying. And then now it doesn't crash. So we might be onto something. It's just that when we nullify that grid, it crashes. Yeah. It says 512 crashed here. I don't get it, because it should just nullify. It's going to nullify the member that we just copied into our milestone members, which is what we want. Because this is the same move locked row, move locked column dot members, grid, move locked row, move locked column dot occupants in all of its fields. So we're just nullifying the thing we just copied into our milestones, which is right, before we increment our occupants or decrement our old occupants. So maybe because, oh, you know what? I think it's right here. Okay, I think it's right here is what's actually crashing. Because back when we had an occupant, we locked in on our stones move locked here. When we're dropping it, or when we're picking it up, we can't have a less than one occupant. Because we have to have greater than one occupant in order to drop, meaning our mouse stone. No. I don't know where I'm going with this. I think it's the -1. Let's see if we take out the -1 in our logic here. If we take this out, we are no longer decrementing the amount of occupants in our first movement grid. Let's just see if that doesn't crash. And if it does, then I think I know how to fix it. Or if it doesn't crash, I think I know how to implement the right version. Let's see. So drop 1, fine. Pick up 1, doesn't crash, but it doesn't pick up 1 either. Mouse stone occupants, still 2. If we drop 2, we crash. Yeah, okay, I don't know what's going on then. It's confusing to me because it's the same logic. It's the same pickup logic as our other right here. Our mouse stack order carries over, so it shouldn't mess up anything. No, I'm a little stumped, to be honest. Let me just check, like go back to the basics. We're going to print out our dropped in first movement and our first movement stones dropped, so that we can just verify that this code would be running. Because we would have to, yeah. Pretty sure that's working okay. But I don't know what else to test at this point. So what we're going to do is go down here to our old debugging. We're going to turn all of our old debugging off. Then we're going to copy another stack of it so that we could only turn on a couple specific ones, which is going to be our dropped in movement grid. Is that right? When we pick up stones, this first movement stones dropped, that signifies whether or not we can pick up a stone. No. This is jacked. I mean, this isn't implemented yet. It'll always be false, so we don't need to print that up. Let's just make sure this is bigger than 1 once we drop. So we'll turn off all of these. And we'll put right here. We want to do a string that says dropped in first movement, and we want to concatenate an integer into a string with our other string, dropped in first movement. The X and Y on the screen there. So now we'll be able to at least keep track of if that variable is going right. Dropped in first movement stone, so move type move. We lock it in, we drop one. We lock it in the first movement, we drop one, drop two, drop three. That's working fine. Now when we press up, it's not going higher. So like, why does pressing up do anything there? Yet it crashes another. Well, I mean, it just crashed, but let's go to the basics. And all we're gonna do is if dropped in first movement is greater than 1, which it was once we dropped something, all we want to do is decrement that dropped in first movement. Okay? It shouldn't crash. It should just update that value. And if that's not working, then I really need to figure out what's going on. Okay. Just dropped one. I'm going to press up. That should go back to 0. It does not. It does if it's... See, it should go back to 0 if we have 1 dropped. Greater than or equal to 1. Lock it in, drop 1, back to 0, yes. And then drop 2, we can still, okay. This is working closer, so let's try turning on one more thing at this point. Actually, let me see if the less than 1 was causing the crash there, or the equal to 1 omission causing the crash. Let's see. Lock it in, drop 1, pick up 1, we're still crashing. So, so yeah, we only want to pick up a stone if we had okay, so there's one thing I didn't think about that we need to ensure doesn't happen, and that's not dropping any stone and locking in the movement, because you have to drop at least 1 stone. So upon enter, we have to say if enter or return was pressed and are dropped in first movement, is greater than 1, meaning we have dropped at least 1, greater than or equal to 1, then we would lock in our first movement stones actually dropped. So for right now, pressing up at least works and doesn't crash if we have all of that turned off. So let's see, move type move, let's lock it in, let's place it. Now drop, drop, drop. We should be able to pick up, pick up, pick up. And it doesn't allow us to pick up any we haven't dropped. So that seems to be working. So now we just need to get into, let's make sure our move lock row and move lock column are actually correct. It should be our first row. So our brackets 1 at column 2. So it should be grid 1, 2 in that space directly to the right of our tester. So we'll put in a variable here. Actually, yeah, we just need this. So move locked row. So we're going to call it move locked row. And then also put in our move lock column. And if this is wrong, then we know what's causing our mistake. And if it's not this, I don't know what else to test, but let's see. Okay, so we've got placement, lock it in. We need $320 on the Y there, so they're not overlapping. Okay. It's right. Row 1, 2. That's what we were hoping it would be. Okay, that's weird. It stopped letting us drop stuff. So we can drop one, we could pick up one. Okay, that's just weird. I should just hit R to reset that. Okay. So what's really weird is it'll allow us to do that kind of right, but then when if we lock in here, if we drop in one, pick it up, pick it up, drop in one, pick it up, and then it can't drop anymore. Why can't it drop anymore once we've picked it up? I'm so confused by that. So here we've got 0 dropped in. Oh, it's because, you know what? We must be nullifying this stuff. We must be nullifying this stuff earlier. And that's why it's messing up. This must be happening. Yeah, this is happening. This is exactly why it's wrong. Okay, so we need to add not only not stones and hand locked, but we need to be not first movement stones dropped or grid locked. Not grid locked. Okay, let me see if that fixes something, because I think that's the only thing that made sense. That's making more sense now why everything was busted. So we can drop one, pick up one, drop one, pick up one, drop one, pick up one. We're still not able to drop one. And I think it's because, God, yeah, we gotta still be nullifying it somehow. I'm gonna not put that quite there yet. Okay. I'm gonna put a little Boolean, or a little Boolean flag in here that just sort of gets switched only if this code is executed. So we're gonna say, because this would be dropping it in the movement origin. So we're gonna say drop movement origin DMO tag gets true or false. So we've got a DMO tag that's gonna be false, and we're just gonna swap this with a ternary operator upon every use of it in our movement, in our dropped in movement origin. So right here, when we drop this in our movement origin, we're gonna say DMO gets assigned to be the opposite of what it currently is. So the ternary operator is where we say DMO equals false and true or false. I think that's right, because what it's saying is this is evaluating if it's false. Actually, I'm not sure. Let me look it up. I've never done it with a Boolean before. I've only done it with equal to like an integer or something. I really like ternary operator though. It's cool. See, look. So it's not an equality. It's just an assignment, and then I don't know how it works, actually. I don't know how it's working. It made sense to me when it was integers, but not with true or false. But I guess it's not really different. This page is making me confused about it. Basically, we just want to flip. We want to flip what it currently is. No matter what it is, we just want to flip it. So I know we do that at some point for maybe our mouse toggle. Maybe? Yes. So look. Okay, so yeah, we need to. That's what I'm missing. We need to ask it a question. Hey, is help state 1? And then if it is, it'll be the first one. If it's not, it'll be the second one. So we need to say that the DMO dropped in movement origin upon dropping here. We're trying to test whether or not it's trying to drop, and whether or not it's running the code for our dropping in our movement origin versus dropping in our first movement locked. So that's what we're trying to test here. Where is our DMO though? We took it out over here. So we need to say DMO gets DMO equal to false. And I think we need it to be, since we initialize it as false. Actually, no, I had it right. Since we initialize it as false, we're testing if it's equal to false. And if it is, it'll become true. If it's not, it'll become false. So I want to see in both the dropping and picking up, this DMO is getting triggered. Absolutely should not be. So we're going to be putting in another debugging field. Okay, oopsie. Okay, come on. Actually, this one. Okay. Now, this needs to be 370. And we'll delete the 370 line so we don't have to deal with that again. Now, this is DMO. And we're printing whether or not it is true or false. So we're concatenating that boolean to a string. And printing that up. So it should be false. And then it should work fine for our dropping and moving origin grid, and then we want to see if it's still changing. So look, DMO's false. Let's move type move. Now it should be true when we drop one, which it is, and if we pick up one, it should be alternating anytime we drop or pick up one, which it does seem to be doing. Now let's lock in our first movement grid. Now if we press down, this should not become true. Up should not become true. Okay. So it isn't happening. So now I'm almost more confused because I thought that's what was happening. And we did take out our fix for that, right? We had put... Yeah, we took out our fix. It's just in nut stones and hand locked. You know what? Is our... Huh. No, we would have it right here. Yeah, we already got this turned off. That's so strange to me. I'm gonna comment this out real quick. Because I honestly don't know what's fucking it up, so it's kind of confusing to me. Try to have as little things as possible to mess up. Yeah. Adding our fix here wouldn't have changed anything because we don't become falsified in our stones hand locked upon our first movement grid locked. Because that was causing some other bugs. I'm really confused. And our move lock row is right, our move lock column is right, and our lowest milestone stack order seems to be right too. Let's do this anyway. So we're gonna say lowest milestone stack order. And we're going to put it at what? Let's just see if our lowest milestone stack order is even kind of working. Okay, lowest milestone stack order 1. See, this should be 0. But it doesn't really matter, it's just when we pick it up. Oh no, I guess it makes sense to be 1. So yeah, 2, 3, that's correct, because this is a stack order of 3 stone. Now, if we select this one, 2, 3, it's still correct. Well, that actually is making more reason. We're not decrementing it upon a pickup currently, but I think that's part of the logic we already turned off. Here. Yep. So let's add this back in. See if this is working. Actually, instead of copying that, I'm really just going to delete it. Okay. Okay, let's lock it in, lock it in. See, that should be lowest stack order 3 now. And now it should be... It's hard to say because we're not actually moving stones. But I dropped one, picked one up, dropped one, picked one up. So it should be lowest stack order of 1. Why is pressing up not decrementing our lowest milestone stack order? Lock it in, lock it in. So pressing down should increment our lowest milestone stack order right here, which it does. Now when we press up, it should go back to 3. It should get... Hold on a sec. I'm confusing myself. Lock it in, lock it in. Okay, stack order's 1, because it's the bottommost white stone. Stack order's 2, signifying the next one, but if we pick this up, it should get higher. That stack order should get higher, and it doesn't. Stack order upon picking up should get higher, not lower. But we get higher upon dropping. No, we don't. Yes, we do. Okay. And we do this after, so this can be nice and clean. So dropping a stone increases our mouse stack order. Is that correct? Increases. Yes, it does. Because it's 1. Dropping it increases it. Picking it up should decrease it. So picking it up should decrease it, but it's not. Why is it not? That's so confusing to me. If 1 is already dropped, we not only decrement our dropped in first movement, but we decrement our lowest milestone stack order. So if we're decrementing our dropped in first space, that line of code is executing. So watch the dropped in first movement and the stack order. This one should become 1. This one should become 2. Then when we pick it up, this should become back to 0, and this should be back to 1. So we drop 1 and 2. Now if we pick up, it should be 0 and 1. But if we pick up, this is 0, but this is not 1. So how are we executing this line of code and not this line of code when they're right here? This is the only line we're using dropped in first movement, no? Yes. 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 We're using it here if we're not stones and hand locked, but we are stones and hand locked. That's the only thing I could think of. So if we say, for example, if we go back to that fix we tried and said, and first movement grid, and not first movement grid locked. Actually, stones dropped. If we're not stones dropped yet, actually, yeah, let's do the grid locked. Because as soon as our grid's locked, we shouldn't be able to use this code anymore. Okay. Now let's see if our decrements on our stack order is working. Lock it in, lock it in. Okay. Okay. So now when we press up, this should become 0, this should become 1. It does not. What? 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 Like, what? This is, actually I did this in the wrong space. No, we didn't. No, we didn't. Bro. I don't know what's going on. The only thing I could think of is where if pressing up would also... Here, look. Let's just try this. -2. Now you better decrement. Okay, pressing up. We're hoping that this one decrements to 1. This one decrements to 0. I'm pressing up. I'm doing the wrong thing. We need a decrement. Oh, that was right. But our lowest milestone stack order needs to be decremented. Here, we'll do 2 on this on the milestone stack order. That's what I want to try. I'm trying to figure out if something's canceling that out or not, which it has to be. We drop 1, that goes up to 2. Now pressing up means this should be 1. Gosh, it's really not. Okay, I've got an idea. Or I think this is actually our lowest milestone stack order is only assigned to be what our mouse's literal lowest stone stack order is. So when we're dropping it, fuck, it's so confusing. You know, I think let's take a look at where our lowest milestone stack order is being updated. And just take a look at that code real quick. Right here. We cycle through all of our members and we assign our lowest milestone stack order to be equal to the stack order of the highest member that isn't nil. No. This is wrong, man. This is wrong. This guy does some really cool streams, by the way. I was just wanting tack on screen. Okay, where do we even start with this? So look, this is called assign lowest milestone stack order. Now, We're starting at 10, we're decrementing, and we're saying if the member if the highest member, actually, yeah, we need a break. Don't we need a break if, I'm gonna lose my mind. Yeah, we're saying if it's not nil, then assign that stack order to be equal to our lowest milestone stack order. But it'll go until it'll get the lowest milestone stack order. Because it'll, like, if there's 3 stones, members 3 will not be nil, so it's saying, okay, members 3 stack order, which is 3, gets assigned to mouse stack order, which is 3, and then it'll continue to decrement, and then it'll say members 2, which isn't nil, so members 2, which is index 2, gets into lowest milestone stack order, all the way down to 1. So this does overwrite our mouse stack order with literally what's ever in our mouse. So if we're controlling what we drop into a space with our mouse and its occupants, it's gonna mess up. It's gonna mess up because this is, yeah. See, this isn't even right. We shouldn't even decrement our stack order because our stack order is kind of set by itself. We loop through and do the stack order, so we shouldn't actually need to do the stack order if that's the case. Let me see if we've screwed up anything in our first drop. So drop, pick up. It does. Dude. Okay. It's really jacked. It's really jacked. Okay, I think what needs to happen is we need to not do this every frame. We need to only do it when we ask. Because our milestone stack order should be capable of keeping track. Once we pick up stones in our hand, we should be able to keep track of what our lowest milestone stack order is based on how many we've dropped or picked up. So we shouldn't have to do this every frame. Especially when our dropping up and picking up logic is modifying that value. Because we're modifying it and then we're going through and then reassigning it based on a certain value that is only that on the next frame is going to screw up the next order because we've just thrown it all out of whack. So I'm not exactly sure we need this at all, because we should assign this lowest milestone stack order. We should assign it right when we pick up something. Let me see, lowest milestone stack order let's assign it to 0. And then as soon as we pick something up, we assign it. Yeah, we assign it. Yeah, we should be okay with getting rid of that. Let's see. My bad, bro. My bad. See, we're not dropping the next stone. Okay. But upon dropping a stone, we should increment our lowest milestone stack order, right? See, and This is very confusing to me. Let me put back on. Oh, well, first of all, let's put this back on. Let's put this back on. Let's keep our override here turned off for now. And let's just see if this is rendering stones even kind of right now that we've got those ones turned on. I'm hoping it does. Okay. Okay, thank God. So that's not all broken. So let's lock it in. We place this, drop one, pick it up. Hey, look, we're actually modifying our stack order now, which is what we've been trying to do. So let's see if we turn this back on, if any magic is happening finally, now that we've fixed that weird bug. Lock it in, drop, pick up, and we're crashing still. Let's see if we drop two, then try to pick up one. Let's see if it still crashes. Lock it in, drop two, pick up one, still crashes. What if we do this after everything? At this point, I'm just guessing. I don't even know what's going on with it. I feel like I've tried everything. It's a little defeating, to be honest. It's something to do. Yeah, let me see if... Like, literally the only thing I have left to guess is to render one of every member's field of our grid 1, 2, and see if it's assigning the first one upon that first drop correctly, and then, well, if picking it up is crashing it, that I really don't know what to test. I just don't know why it's crashing. 517, attempt to index a nil value. So 517, now where is it accessing a nil value? Why would it crash at 517, not 516, where we're using the same? Really? I really did just have a little bug right here. I really did. We still needed to fix that other bug, so I'm glad we found that. That's a tricky one. So I'm not like beating myself up over missing that, but let's just be able to pick up stones for once, dude. Thank God. Okay, thank God. Now, here's the real test. If we drop all three, can we pick up one? Yo, we can. We really can. And then if we hit enter, we lock that in, and then we should stop rendering stuff, but wow, Jesus, okay. So yeah, we had one little bug hidden in here, and this is why they say not to copy and paste code, because I copied and pasted the code from up here, and I didn't change this grid. I changed all but that one. But our debugging let us know that it was on a line after we had supposedly done a similar thing to the exact same line, and we had found the bug that way. So we need to do a couple of, this is just our first movement stone. If we pick up 5 stones, we can not drop any. We can just move to the next stone, lock in our direction. We can drop 1 stone. That's our first movement grid. Then we can move in front of that, drop another one. That's our second movement grid, which we don't have yet. And then there's even a third and a fourth if you pick up 5 and only drop 1 in every space. So we'll need to continue this logic, swapping the booleans so that we can only drop in the appropriate squares, not the old squares. We can actually probably do it a little smarter by doing it based on this move locked row that gets updated, which we are actually doing. I just don't want to take any chances that we're accidentally decrementing our milestone stack order more than once, because that's the problem that comes into it. Yeah, there's different ways of doing it. Part of me wants to just keep expanding the way I have done it, but another part of me is saying just take the time to do it right. Because if you are allowed to drop a stone, you should drop a stone in your move locked row and column. Easy enough, and nullify the milestone. And if you pick one up, you can only do it if you've dropped one there. So instead of having for 5 movements, we have this instead of keeping track of, or is it? Do we not initialize it? Dropped in first movement. Yeah, we have it. So see how we've got 1 value for dropped in movement origin, 1 value for dropped in first movement. Those are only to control how many we can drop in a new move locked row. So if we have 4 movements total, we would have 4 variables for that, but we really only need to keep track of how many are dropped. And then upon locking in a drop, if you still have more stones to drop, it'll get reset. So, or it should get reset. So there is a smarter way to do this. It's just a little scary because now that I got something working, I'm wanting to not change it, but there is a much better way to go about it. But I don't know. It's like is it one of those things where we just get it working, period, and then we go back and try to fix it? Or, you know, I'm kind of leaning towards that, where it's like, just get it working, then you can worry about optimizing it. Because the momentum on a project like this is really starting to affect me. Because if I wouldn't have been able to fix that thing today, tomorrow programming would have been very hard for me to get going on. So thankfully we at least figured that out. Let's take a look at our git diff here. We added this DMO boolean to trigger, to test whether or not we were actually triggering more than 1 line of code at once for our dropping and picking up, which it turns out we weren't. We took out a whole thing where we assign our lowest mouse stack order, which was a bug that was screwing up a lot of stuff, and we got some new debugging. So we really didn't do much except find a bug that was really screwing up some stuff. But we can commit saying we added stone drops into our first movement grid locked. And we can drop all of them, which is nice. If we drop all of them and lock it in that we need to end our turn, we still have occupants left over in our milestones. We need to continue our legal moves, but only in the direction that we've locked in. We've already got the lock-in direction. We just need to add the arithmetic for our legal moves, depending on which stage of our move we're in. So that'll be next. But I'm really relieved we figured out some of those weird bugs, because that was just super confusing to me. I'm going to push it, and I will see you guys tomorrow. I got a big work day tomorrow. I got probably a 12-hour day tomorrow. Actually, probably more, maybe 13 hours. So I'm thinking I'm going to get home and still program, but after a 13-hour workday, I might just be completely toast. So we'll see. I'll do my best to at least do 5 minutes of programming tomorrow, so I don't miss a day, or stay working on this.